In this episode, we're going to revisit a topic of a new rover.
In episode 29, Lucy and I built a Snap Circuits rover, but it was purely a remote-controlled vehicle. From the beginning, Lucy wanted to put together one that she could actually program. So this past April, I started investigating what that would take, and here's what we came up with.
A Daegu 4-wheel drive rover chassis, a Raspberry Pi 2.
Pie.
Not that kind of pie, Dad. Next, a wireless USB dongle, some male to female hookup wires, a rechargeable battery with a micro USB connector.
We could have tried a simple battery pack with AA batteries, but I wanted to make sure the Raspberry Pi had a steady 5 volts supply going in. The motors themselves actually have their own battery pack, a set of 4 AA's, but they aren't, and we can do that because they aren't as sensitive to power fluctuations as the Raspberry Pi is. Rounding out our parts list was a small breadboard that we'll hook everything together with, and 2 TB6612 FNG motor drivers from SparkFun. I'll put a link in the to the SparkFun page on these in the show notes. Each board is capable of running 2 motors. Since the Daegu chassis was a 4-wheel drive vehicle, we actually needed 2 of these. To get these motor drivers ready to be used on the breadboard, I soldered a set of straight headers onto the chips. I also made the call to solder them in upside down. SparkFun printed which pin was which on the bottom of the board, and I didn't want to have to keep turning the chip over to see which pin to plug into next.
Alright, let's get to the building. We started by putting together the chassis. The first thing Dad noticed was that the motors came with no wires at all.
At which point, I had Lucy go on with putting the chassis together while I frantically soldered wires onto the motors.
Of course, the first thing I had to do was, wait for it, mount the motors.
Once I had the wires soldered onto the motors, and we got past a false start with the actual mounting brackets, we did get everything for the bottom part of the chassis put together.
Then it was time for the wheels themselves. I was really looking forward to doing that part.
Those went on fairly quickly. With the wheels on, we fed the wires up through the bottom of the chassis, and then one of the wires broke off. Actually, the lead running into the motor itself broke. The thin pieces of copper that they attached to the motors were just not strong enough to handle any amount of movement.
Dad reattached the broken lead, and then we zip-tied the wires for each motor itself. Zip ties are a wonderful invention. They rank right up there with duct tape.
Or pie, which we'll be adding to the Rover in here in a couple of minutes.
Dad, I told you not that kind of pie. At any rate, now that we had the bottom part of the chassis completed, Dad added the posts for the top. And then I attached the top itself.
Phase 2 involved adding all of the other electronics, and actually getting this thing to move. I started by plugging in the motors to the breadboard, and connecting them to the appropriate pins on the motor drivers. Next, I wired one of the motor drivers up to the Raspberry Pi.
Dad, it's starting to get a little messy, isn't it?
Yes, it is, but that's what breadboarding looks like. But this way, we can completely tear the Rover down later and reuse the parts for other projects. I should also mention that getting the Raspberry Pi configured for our use here, and getting it wired up to the breadboard, for the most part, was very easy. I'll be writing up a more detailed account of everything that went into that on my technical blog. I'll put a link to that in the show notes here as well. The programming language Python came pre-bundled with the operating system for the Raspberry Pi, and it was very easy to write a program that would get the wheels turning. I went ahead and wired up the second motor driver and fleshed out the core of the program that would control all 4 wheels.
Okay, I take that back. Now it looks messy.
Up to this point, I had just placed the breadboard and the Raspberry Pi onto the top of the Rover, and I noticed when it was moving around that they were sliding around a bit. I decided to zip tie them down, just tightly enough to keep them from falling off the chassis. And only afterwards realized that I had tied the Raspberry Pi down so that the micro USB power jack was now completely blocked. So I cut the zip tie and rotated the Raspberry Pi. There, much better.
That surprised me a few nights ago with the completed Rover, and I couldn't wait to take it out for a spin.
The Rover has 4 basic commands: move forward, move backward, turn left, and turn right. I had intended the X parameters to be the number of centimeters to move, but the DC motors we're using are just not that accurate. Giving move forward and move backward commands, giving those 2 commands a higher number will move the Rover more, but other than that, the number really doesn't mean anything at this point. We started in the kitchen, since it wasn't carpeted, and quickly discovered that the tiling in the kitchen makes an awesome grid system. The Rover perfectly fit into each square, and then we could plot out where we wanted it to go using sticky notes, and then plan out what the program would look like to get it there.
Dad came up with the first problem: move forward 2 squares, turn, and then move 3 squares. I then came up with the commands that I thought would work to do that. I uploaded my program to the Raspberry Pi and then ran it. It didn't quite make it to the right square, so I tweaked the program and tried it again. It was really easy to make a change and try it again. And of course, it was lots of fun.
We'll leave you with a couple of quick videos showing the Rover in action. So this is the first test of the Raspberry Pi Rover. It's going to move backward, turn left, turn right, and then move forward again. So, got a little bit more work to do on calibration, and got to get the battery hooked up so it's not on a tether. But otherwise, the raw bits are there. 1.
Come here, boy. Come here, boy. Come here, boy.
Oh!
Good boy. I can't believe I didn't think of this before. We could call the Rover just Rover. You know, like a dog Rover.
A red dog?
Well, we could call him Clifford.
Nice.
Or, you know, we could just chant Red Rover, before running the program.
Ah.